After having talked about preference relations in the previous chapter, we now come to indifference curves, which is one way of representing preferences. So one very common way to illustrate preferences graphically is by using indifference curves. And such an indifference curve would connect all the consumption bundles across which a consumer would be indifferent. So along such a curve, it would not matter whether a consumer chooses consumption bundle A or B as long as they are on the same curve. Bundles that are above the curve or further away from the origin, they are strictly preferred, and bundles that are below the curve or closer to the origin would be strictly dominated. And that means basically that it reflects the monotonicity of preferences, so that more is always better, and to the left of the indifference curve we would have less, and to the right of the indifference curve or further away from the origin we would have more. So let's illustrate this with a very simple example to start with that depicts two perfect substitutes. So assume that you need to buy gasoline and you have two stations in your city. One is on the left side of the street, the other one on the right side of the street. And you want to fill up your tank, say 30 times a year. Then it doesn't matter whether you do this at station 1 or at station 2, because gasoline is a very homogeneous product. There is no, so they are really perfect substitutes. It doesn't matter for you whether you fill your tank on the left side or the right side of the street. So you can fill up your tank at station 1 all the time, or at station 2 all the times, or any combinations in between that lie on the straight line from this use of just station 1 to this use of just station 2. So that would be straightforward. All these points along this line are consumption bundles for which you as a consumer are indifferent. So you would be indifferent between filling up 30 times at station 1 and 0 times at station 2, or the other way around, or 25 times at station 1 and 5 times at station 2, and so on and so forth. Now, consumption bundles that are to the left of this curve, so closer to the origin, that means basically that you can fill up your tank less than 30 times a year. And these are strictly dominated bundles, because you want to fill up your tank 30 times a year. And the ones above, they would be strictly preferred bundles, because that would mean that you can fill up the tank 35 times, say, a year, and that would be strictly preferred because you can fill up your tank more often. And note that here the budget constraint does not play a role yet. Later on, of course, we will introduce a budget constraint that will put limits on what the consumer can basically buy. But here the important thing is just the indifference curve is here. These are all the points for which the consumer is indifferent. Here is the set that is strictly dominated, so all points along the indifference curve are better than the ones in this set, and all the consumption bundles in this set, they are strictly preferred to the consumption bundles along the indifference curve, so that's also called the better set. So the previous case was a very particular one, a special case of perfect substitutes, where the consumer doesn't really care whether he or she buys good 1 or good 2, where we just assumed that it is actually the same good but provided by two different providers. Now we have the other polar case, perfect complements. And the example that is very frequently given for perfect complements is that of left and right shoes. So if you buy a right shoe, you would also need a left shoe. There is no point in buying, say, 10 right shoes and only 2 left shoes, so there is no substitutability between the two. If you want to have a pair of shoes, you buy a right one and a left one together. In this case, the indifference curves would be in a 90 degrees angle towards each other and look like these ones here, where now you are indifferent between all the points along these horizontal and vertical lines, which means that if you have one right shoe and one left shoe, You are equally well off if you have 10 left shoes and one right shoe, or 10 right shoes and one left shoe. So the additional shoes don't matter to you if they are not complemented by another shoe for the other leg, right? The better set is now the set in which you can buy more shoes of both types. So the next best allocation for you would be the one where you have 2 right shoes and 2 left shoes, and you dominate the ones to the left here. So the indifference curves are in a right angle towards each other, the better sets are to the right, and the dominated sets are to the left. For most of the goods, indifference curves would look like these ones here, where there is a certain degree of substitutability, but no perfect substitutability. Think of this, for example, as scoops of chocolate ice cream and scoops of vanilla ice cream, where people usually tend to prefer a mixture of both. So if you have two scoops that you buy and you have two different sorts of ice cream, then most people take a mixture of both, except if they don't like one of them at all, right? So that would be then an indifference curve that is bulged towards the origin. So if you are at the point where you have, say, many scoops of chocolate ice cream, but only a little of vanilla ice cream, then one additional scoop of chocolate ice cream would not be that valuable to you than one additional scoop of vanilla ice cream, right? So you would move strongly along the vertical axis, but only little on the horizontal axis. So a little bit of additional vanilla ice cream would be worth a lot in terms of sacrificing chocolate ice cream. Again, there are now different indifference curves drawn. If you start with this one here, the one to the left would mean that you have fewer um, possibilities to buy scoops of ice cream, so you would be worse off. And here you would have, say, more money to buy more ice cream, and you would be better off. Then this property of indifference curves that in case of substitutability that is not perfect, that they are bulged towards the origin, that's called the love of variety. So people tend to have a love of variety. If you have different goods to choose from, people prefer a mixture of the goods to the extremes where they only have one of them, except, as I said again, if you dislike one of them in general. Now here this is described verbally, so for most of the goods that we have, except for the perfect substitutes, there is a love of variety effect. So the consumers prefer the combinations or mixtures of goods to the extremes of consuming only one of them. And in this case, indifference curves are bulged towards the origin, or in mathematical terms, that means that preferences are convex, such that a better set is a convex set. What does this mean? Well, if you take the indifference curve, you have the better set to the right here, so away from the origin. And if it is a convex set, then mathematically it means that the linear combination of 2 points that lie on the border of this set, they will be inside the set. So if you compare consumption bundle A to consumption bundle B, then a consumer who can buy a linear combination of the two, so kind of a mixture that is more balanced between the two, will always be better off. So it will be to the right of the indifference curve. So it would be along this line here if you buy a linear combination of the two goods instead of the extremes that are on the boundary, and that means that the set here, the better set, is convex. All linear combinations along a straight line lie within this set. Another important property of indifference curves is that they cannot intersect. So for illustration, take again the indifference curve that we have here between two goods, now called x and y. And then you have a second indifference curve, and that this indifference curve intersects the first one. That is impossible. Why is this the case? Because it violates the transitivity of preferences. You see this here. So for example, at this point here, a point along this other indifference curve would be strictly preferred to a point along the indifference curve on this set, right? But if we are here, then a point along this indifference curve up to here would be preferred to a point along this indifference curve. And that would mean that the preferences are not transitive, they are not consistent, because depending on where you are on the difference curve, you would prefer one to the other good, or the other bundle, but this would then be inconsistent with the behavior on another set of the indifference curve. So indifference curves can never intersect, which is a consequence of the transitivity assumption of preferences. So we can summarize now everything we've learned about indifference curves in this chapter. So the first thing is that preferences can be illustrated by such indifference curves, and the shapes of the different indifference curves, they reflect whether the goods are perfect complements, then you would have straight lines, perfect substitutes, then you would have lines that stand in a 90-degree angle towards each other. Or if you have certain standard goods with a certain degree of substitutability, then you would have curves that are bulged towards the origin. That's also called the love of variety effect. And except for perfect substitutes, that's the case, so that the indifference curves are strictly convex, and that's nothing else than this statement that they are bulged towards the origin. And this also implies that the beta set is a strictly convex set, as we've illustrated before. There is also the monotonicity assumption. So again, more is better. So the more of the goods you have, the better off you are. So if you move to the right from the indifference curve, so away from the origin, it would be better. And if you move towards the origin, you would be worse off. And indifference curves cannot intersect. Thank you very much for watching the video, and I hope you found it interesting and useful. For more videos on economic content, please visit my channel that you find here to the left. And to the right, you see the next video in the series at the top, and at the bottom, you see the whole lecture in the form of a playlist.